Ji, Bismillahirrahmanirrahim. Thank you very much for the channel. Now, today we are discussing about the basic concept of how to calculate half-life by using the zero-order data. And in case of zero-order data, we all know very well, zero-order data depends on the time, and it will not depend on the concentration. And when we construct a zero-order data, we have a straight line profile in rectilinear. We have already explained in our previous video. In case of rectilinear graph, here is a concentration and there is a time. And in case with the start of concentration 0, say 10, 20, 30, and in case of time we have 0 time, 2 hour, 4 hour, 6 hour, 8 hour and 10 hour. I have made the profile of the IV injection when we have the profile of zero order. In case of zero order, we have assumed that there is a straight line in case of as we constructing the rectilinear graph. We have the equation y is equal to mx minus b here. Why I am writing here minus mx plus b here? Why I am writing minus m? Because m would be in the slope would be in the negative form. When we take the ratio of these two concentrations, for example, if it is a C1 and 10 is the C2 and time 2 and 4 are the time, then we will write C2 minus C1 over T2 minus T1 is the slope. And in case of C2 we have 10 and C1 is 20 and 4 minus 2, so we'll get minus 10 divided by 2, answer is minus 5. This is our slope which is in negative form. But our basic concept is how can we calculate the half-life of from this data. Data is zero order. We have to construct the rectilinear, and rectilinear graph would be in the straight line. Now our equation would be, we will assume that if we have y is equal to mx plus b, which is actually Cp is equal to k t plus Cp naught in case of this type of the data. And when we have to take exact half of the concentration, then we will assume that the concentration at the time at which half of the concentration available in the body. In case of half-life, we assume that the concentration which is remained, the time at which half of the concentration remained in the body. So when we convert this Cp naught into point Cp, then we will say this time is T half. We have to write 0.5 Cp naught in respect to the Cp naught, Cp naught 0.5 Cp. Then we can get the half-life. Okay, Kt half is equal to Cp minus Cp naught. Now we have to write Cp minus 0.5 Cp K2. Okay, when we take the common of the Cp, it's 1 minus 0.5 and Kt half. So it's a 0.5 Cp naught over Kt half. And now formula for the half-life in case of zero order is T half is equal to 0.5 Cp over K. Cp naught over K naught. This is the formula for half-life of zero order rate constant. For example, in this data, if we want to calculate the half-life of this type of the data, we will first search the initial concentration, then multiply it with the 0.5 and then divide with the K. I will explain this K because this K is equal to this M. In this case, we will calculate first K, that rate constant K is C2 minus C1 over T2 minus T1. Remember in my previous video, we have written the same word with the ln C2 minus ln C1. because the data was plotted on the semi-log graph. And in case of rectilinear graph, we will have to just taking the simple values of C2 minus C1 over T2 minus T1. Okay, if we have the negative value, for example, well, negative value of the K and positive value of the CP naught, then we can assume that this concentration is basically where we have to even not mention any type of the negative sign with the half-life, because time would not be in the negative form. We will have to write the CP naught concentration, then with the K, then we can get the half-life of the drug. This is all about the half-life of drug, calculating of half-life by using the zero order concept. Of this type of the profile, say I will make the same scenario of concentration and time. Now we have for example, we have here 2, then we have the value of the 20. At 4 we have the value of the 10. At 6 we have the value of the 5. When we make these type of the data, just like in our practical book, you can, in our exercise book, you can see the exercise of the exercise number 4, which is given by the same profile of data. In this profile, we will first calculate K. For example, we have calculated here -5 is the K, and then where we want to check the half-life of this data. Our basic assumption is we have to calculate the about the where it is 50. For example, it's a 40, then it should be a 50. We have to calculate the time where the 50 would be the answer. So we will write here CP naught first. For example, if we have the CP naught here 35, so we will write the 0.5, 35, and divided by 5K. Then we can get the half-life of this profile. So this would be the half-life of the data by using the rectilinear plot, by using the zero order concept.